Welcome to this week's lesson on the electromagnetic spectrum. You should be following along as you're watching this video, filling in the notes that are outlined on Microsoft Teams. So this week, we are talking about specific types of waves called electromagnetic waves. Last week, we discussed different wave properties such as transverse waves and longitudinal waves, their frequency, how to find the wavelength, etc. This week, when we're looking at the electromagnetic spectrum, we will be looking at a whole range of waves at different wavelengths. The EM spectrum is the whole range of EM waves in order of increasing frequency and decreasing wavelength. This means as you go from left to right on the chart, the wavelengths get smaller and the frequency gets larger. As you can see here on the left, the wavelengths can span from the length of a soccer field and a house to the length of a baseball to this tiny little period to the size of a cell. And they continue to get smaller and smaller and smaller all the way to the right. Down below, you can see the different sources of these electromagnetic spectrums that we'll get into more detail with in just a few slides. So some things to remember. The higher the frequency, the more energy the wave has. Electromagnetic waves do not require media in which to travel or move. Therefore, they travel throughout space and reach us here on Earth. EM waves are considered to be transverse waves because they are made of vibrating electric and magnetic fields at right angles to each other and to the direction of the waves are traveling. Inverse relationship between wave size and frequency exists. So as wavelengths get smaller, frequencies get higher. Remember, all EM waves travel at the same speed. The equation for speed is wavelength times the frequency. So for the answer to always be 300,000 kilometers per second, as one number goes up, the other must go down. All EM waves are radiation. The higher the frequency, the more energy in the wave. So, in more detail, the waves, starting with the longest wavelength, which is the radio waves. They can go from thousands of meters to 0.001 meters. The shortest radio waves are the microwaves. Radio waves are used for radar, sending sound, pictures, cell phones, cooking food, and satellite transmissions. Infrared waves are slightly shorter in wavelength, from 0.001 meters to 700 nanometers, and have slightly higher frequency. Infrared is used for finding people in the dark and used in your TV remote. Visible light is what we can see in the electromagnetic spectrum. It's the only part of the spectrum that we can see with the naked eye. Wavelengths of visible light go from about 700 nanometers, which is red light, to about 400 nanometers, which is violet light. The frequencies are higher than infrared. So a quick note on remembering the order. So just like you would see in a rainbow, we have Roy G. Biv. You might have heard of this before. So the longer the wavelength is in red, then it goes orange, yellow, green, blue, violet. Violet has shorter wavelengths and higher frequency. So this example here shows white light being hit in a prism and it disperses into its different wavelengths. The same thing happens when white light hits the raindrop. After it rains, you can start to see it disperses the light into the different wavelengths so you can see a rainbow. Ultraviolet wavelengths form from about 400 nanometers to 10 nanometers. The frequency, and therefore the energy, is high enough with UV rays to penetrate living cells and cause damage. Too much UV can lead to sunburn and skin cancer. However, we do need UV to produce vitamin D in our bodies. UV rays are easily stopped. Although humans cannot see UV light, bees, butterflies, and some small birds and rodents can. X-ray wavelengths are the next in the spectrum and are formed from 10 nanometers to 0.001 nanometers. They have enough energy to penetrate deep into tissues, but are stopped by dense materials. They are used for looking at solid structures such as bones and bridges and for cancer treatments. Gamma rays have the shortest wavelengths, less than 1 trillionth of a meter. Therefore, they have the highest frequencies and carry the most energy. These are the most damaging to tissues. They are very hard to stop. You would need a 3 to 4 foot thick concrete wall to stop them. Gamma rays are released by nuclear reactions in nuclear power plants, by nuclear bombs, and by naturally occurring elements on Earth. They are also sometimes used to do specific targeted treatments for cancer. Here is an example of a person's lung who has asthma. The patient was given a slightly radioactive gas to breathe, and the picture was taken using a gamma camera to detect the radiation. The color shows the airflow in the lungs. So this is where you can find all the different picture sources. But that is it for our electromagnetic spectrum notes. Your activities for the rest of this week will be looking at how we use the electromagnetic spectrum to do all different sorts of things, including ultrasounds, microwaves, radio waves, etc. Thank you very much.